right. Lesson 4.4. We're gonna go over the warm-up. The students were just working on it, so let's see how they did. Number 1, write a congruency statement for the following triangles. So we can see marked here we have some congruent sides, congruent angles. Now it doesn't mark this for us, but obviously this is a shared side, so that's also congruent. So all the corresponding parts of these two triangles are congruent, all the sides and all the angles. So we can conclude the triangles are congruent. So your congruency statement, you would just say triangle. Now if you start with A, B, C, we have to go in that same order. So I started with like the triple arced angle, C, then I went to B, so I'd go to D, A. You could have also said triangle BCA is congruent to DAC, or another one I came up with. Obviously, there's a few options, but these are probably more common ones. You just have to keep the corresponding parts when you list out that congruency statement. Okay. Somebody have something else that they want me to check if that's right? Good. Number 2 was a fun little problem, little algebra mixed in here. They're telling me these two triangles are congruent. It says, if triangle JKL is congruent to QRF, find each missing value. Okay, I'm going to just start with X. So I see X is up here on line segment JL of this triangle. So if I look, JL is listed as like the first and third vertex in that triangle. So what side in the second triangle does it correspond to, Alex? QS, exactly, this one. So if these triangles are congruent, those sides would be congruent. So you should have gotten X to be 5. Okay, good. Y is also on a side length. Over here, it's on RS. If I look up at my congruency statement, RS. So it is congruent to side KL, corresponds to KL. They're telling me KL is 27. So I know Y plus 10 is the same as 27. So you should add Y to be 17. Those ones weren't too bad. Z, kind of hard to see right here, is labeled as angle K of my first triangle. What angle does that correspond to on my second triangle? You can shut it up. R. Yep, R. Middle one right here, R. All right, now I don't know what angle R is. But I know angle S is 87 degrees. And S corresponds to what angle of the first triangle? L. This one. So I know this is 87. And then I see, now I know 58, 87, 4z plus 3. Now I can set up an equation that those have to total 180. Or you could have done 180 minus those two, minus 58, minus 87 would give me that third angle. However you want to set up the equation. Or you could have done 4z plus 3 plus this equals 180. Could have done that as well. I think I actually did that last hour, but whatever, it doesn't matter. You're going to get the same answer either way. So here we got 35. And I subtracted 3. Divide by 4. I got Z to be 8. Those are congruent triangles. How do we do? Good? Okay. In this lesson, we're also proving congruent triangles, but now instead of having to show that every single corresponding side and every single corresponding angle are congruent, to write this congruency statement, there's some shortcuts, and they're mathematically legit, so it's not like it's, oh, if I just know this, then I'm just going to say they're congruent. They are. But basically, it's like if you can prove enough criteria about the two triangles, then the rest are going to be congruent. Now, you don't have to go through and like ever prove why these postulates work. Remember, postulates in math are just something you just accept as the truth, and you're going to have to like apply them when we do proofs. Okay? All right, there's two postulates we're going to talk about today. So if you see the title, you see SSS and SAS and SES. So SSS is short for, it's an abbreviation for side, side, side. And I think it's really fun if you say it really fast, like side to side. Do it. Sorry, you'll do it. Side to side. Side to side. Yeah, it's really fun. Side to side. Everyone want to try it? Side to side. I think you're the fastest. Okay. So basically what this postulate says is if you can show all three sides are congruent in two triangles, then the triangles are congruent. This is true. You couldn't draw two triangles with equal side lengths and different angle measures in the inside. Okay, if the three, again, you don't have to ever prove this, we're just gonna use it. So let's look at this example for a second. You can see side AB is congruent to DE. There's one side. And we can see BC is congruent to EF. And our third side, AC, is congruent. And they're marked for us on these triangles, right? With all those tick marks, all that fun stuff. So if you can show that all three sides are congruent, you don't even have to say anything about the angles. If you can show this, then the two triangles are congruent. You can conclude that using this postulate, side, side, side. It's kind of like that one theorem we talked about where it's like, oh, if two angles in a triangle are congruent, then obviously their third are going to be congruent as well. It's kind of like that. Another like shortcut, like if you can show this, then we can conclude the two triangles are congruent. And again, the reasoning, there's no way to draw two triangles with equal side lengths and different angle measures. So they're going to be congruent every time, no matter what the lengths, as long as they're congruent. Okay, there's our first postulate we're going to talk about today. Side, side, side. Second one is side angle side. Side angle side, SAS. So this one says if two sides and the included, this is important, the angle has to be inside the two sides in order for this postulate to work. The included angles, if that angle and the two sides are congruent that make up the angle, then we can conclude the two triangles are congruent. So look at this example right here, like this picture. So we can see side AB is congruent to side DE. Then we can also see side BC is congruent to EF. Skip the angle part. We'll come back to that in a second. Okay, now I trace those to show you those two sides form an angle, right? In the first triangle, they form angle B. In the second triangle, they form angle E. So if you can show the two sides with their included angle, okay, so not like angle D over here that doesn't touch side EF, the included angle is also congruent. Then we can conclude the two triangles are congruent. Let's see, A, B, C would be D, E, F. So the order matters. Side angle side. Two reasons. One, you have to put the A in the middle because it's the included angle, and you don't want to write a naughty word, right? So make sure you're careful with the order of those letters. That was my funny joke.
Funny joke. Ha ha ha.
Do you get it?
Yeah.
You don't need to explain it to people. Okay.
I can explain it if you want.
Nope. All right, so we're going to do a couple of proofs today using side, 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 and side angle side. And I'm going to introduce you to a new type of proof. And it's fun. It's less writing. It's called a flow proof. And if you've ever seen like a flow chart, it's kind of similar to a flow chart. Do you know what a flow chart is?
Progressive.
Sounds familiar.
No, not flow. That's funny. Okay. Wasn't as funny as my joke, but it was close.
Yeah.
So there's some flow proofs on your homework. So you have to practice them, but I actually think they're easier than the 2 column proofs. It's just less writing, I guess. I shouldn't say easier. So here's what we're given. Obviously, I have this picture here. We're given line segment QU is congruent to line segment AD, and they marked that for us with the 2 hash marks. We're also given that QD is congruent to AU, and they have the 1 hash mark there. All right, they want us to prove that triangle QUD, so it's kind of like the top triangle on that parallelogram, is congruent to ADU. All right, so as a normal like proof, you do have to state what's given to you. Okay, so all of like your reasonings, you're gonna put in little like bubbles. So let's start with what was given to us. QU is congruent to AD, and then you're just gonna kind of put that like in a bubble. And then you put your like reasoning. I guess I should call this is like your statement. You put your reasoning underneath here, given. All right, and then our other one, QD is congruent to AU, given. All right, so I know 2 of the sides of those 2 triangles are congruent. So to use one of these postulates, I either need to show the 3rd side is congruent and do side, 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 or I need to show that their included angle is congruent and use side, angle, side. And I look at this, I'm like, well, they share this 3rd side. So obviously that's congruent to itself. So here's going to be our next statement. Line segment UD is congruent to itself. Ooh, you guys know this. And remember what? Reflexive. Sorry, you're going to say, Jessa? Yeah. Reflexive property. Nice. Okay, so we're going to put that in another bubble. These are all our reasonings. Basically, you're just like organizing your thinking. All our reasonings, and then you draw arrows to your final conclusion. So my final conclusion, because I've now proved all 3 sides are congruent, I can use this conclusion that triangle QUD is congruent to triangle ADU. And I usually box this one. And then you just have to draw arrows. Whoops, like this. These are all my reasonings that allow me to conclude. What postulate did I really use here? Yeah, set aside. Set aside. See, that wasn't too bad. Wasn't it kind of fun?
It's letters.
You'll enjoy it more than the next
Okay.
problem. Okay. We have 3 problems left. Next problem.
Actual numbers.
Triangle DVW has vertices at DVW, all those coordinates, all those ordered pairs. Triangle LPM has vertices at LP and M and all those ordered pairs. Determine whether the 2 triangles are congruent. All right, let's start by graphing these. I will do triangle DVW. I'm going to do that one in blue. So -5, -1. That's point D. -1, -2. That's point B. And -7, -4. is W. So there's that triangle. Cute. LPM, I'm going to do in green. All right, so 1, -5. Is L. 2, -1 is P. 4, -7 is M. All right, I'll give you a second to plot that. Do they kind of look like they could be congruent?
Yes.
Yeah.
I don't think they are.
No.
Well,
I mean, if you turn it the other way, it could be.
PLM look at. All you gotta do
Different.
is do the distance formula of at least like whatever.
Oh, I don't want to do distance formula.
That's what we're gonna do.
I'm not excited.
We're gonna calculate all these side lengths. Because if we can show that all the sides are congruent, we can say the triangles are congruent by side to side.
Oh my god. Yeah, you're right.
Alright. First of all, stop. Second of all, I'll make you a deal. Let's just do the blue triangle. I already did the green one. Well, I did both of them. I'll give you those ones. Let's just practice the blue one, and then I'll give you these ones just to save time, okay?
Okay.
Not because you're boring. Because we've done distance formula like 800 times. Okay, D. I'm going to start with DW. DW, this side.
Oh my gosh.
Okay, DW. So, distance formula, refresher. Subtract the x coordinates, -7 minus -5. Square that. Add the difference of the y coordinates, so subtract the y coordinates, and square that as well. All right, so here we get -7 plus 5. We get -2 squared. -4 plus 1. -3 squared. So we get 4 plus 9 is the square root of 17. All right, 1 down, 3 to go. All right, I'm going to do WV next. Okay, so I'm doing these two. All right, so -7 minus -1 squared plus -4 minus -2 squared. I don't mean to rush through this because it's not important. We've just done this a bunch of times, but it's a good refresher. All right, -7 plus 1, that'd be -6 squared plus -4 minus -2 would be +2, that'd be -2 squared. 36 plus 4 is a square root of 40. You don't really need to simplify the radicals here, folks. We're just checking if all of these are the same. So you can leave it as a square root of 40 for now. I wouldn't recommend getting decimals, so I would just leave it as the radicals. All right, one more, and then I'll give you the green ones. DV. All right, so here I had -1 minus -5 squared plus -2 minus -1 squared. So you get 4 squared plus -1 squared. 16 plus 1 squared is 17. No. Wait a minute. Did I do one wrong? They both aren't square root of 17. 4
The top one.
4 plus 9 is 13. Sorry. Oh my gosh, Chickle. This is what happens when we go too fast. Okay, my bad. I was like, I don't remember them both being 17. Square root of 17, square root of 40, square root of 13. Those are right. Okay, now I will give you these other ones, and you can just write them down. ML ends up being the square root of 13. PM ends up being the square root of 40. And PL ends up being the square root of 17. Square root of 40, PL, square root of 17. So now you can kind of see which sides correspond to which side. ML is square root of 13.
Apparently it is congruent.
So they are congruent. This side's congruent to this side, same length. This side's congruent to this side, and that long side is congruent. So, here's what you have to say. Triangle WDV is congruent to triangle MLP by what? Set aside. All three sides are congruent. Now we're starting to appreciate the proofs a little more, right? That's worse.
I did not miss this one.
Speaking of proofs, we're gonna do two more. What are we in here till 2:45? This is weird schedule. Okay, we'll finish this. No problem. We're gonna do two column proofs. These are kind of fun. They're like puzzles.
Pay attention, Ben.
Okay. So here's what we're given in this next problem. We're given RQ is parallel to TS, and that's marked with the arrows, right? That means parallel. We're also given that those two lines or those two segments are congruent. That's marked with the hash marks. They want us to prove that angle Q is congruent to angle S. That's where we're trying to go. That's our roadmap. All right, so with the two column proofs, we always start with what's given to us. We're just going to restate this. If you don't know where to start, that's what you do. Reason given. All right. What other side is congruent of these two triangles? Alejandro?
RT and TR.
Right. RT is congruent to itself. By reflexive property, yep. Okay, so right now we just know two sides are congruent. So we either have to show the third side's congruent or we have to show these included angles are congruent. And these lines are parallel.
Oh, you could. Through that one thing you think.
Think of this as a transversal of these two parallel lines.
Interior thing.
Yes.
I forgot the name, so someone else.
Why are those two angles congruent? Alternate interior angles. Good. All right. Angle QRT is congruent to angle STR. Alternate interior angle theorem. That's just sort of for theorem. It's kind of sloppy. Oh. Okay. All right, so I have a side angle side situation here. So I can say that the two triangles are congruent now. So I could say triangle QRT is congruent to triangle STR. Pay close attention to the order by side angle side, but that's not what I'm trying to prove. I'm not trying to prove that two triangles are congruent. I'm trying to prove that angle Q is congruent to angle S. Now, if the two triangles are congruent, everything in here is congruent. These are my corresponding angles. Okay, I'll be impressed if you can get this. Anybody know why I could jump to here, like what my justification would be? Do you have an idea, Gwen?
Is it the third triangle?
Nope. Good guess though. I like your thinking. It's from a previous lesson. Somebody got it last hour. No pressure.
This is
Probably.
this
Let's
hour.
just
This
start
is this
with-
hour.
C.
Corresponding.
Corresponding parts
All that.
of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. CP, CTC. Oh, so many good things that we've learned all in one. All right, we got to do one more, so let's hustle. Sorry, do you need that? Okay. Here's what we're given. Segment EI is congruent to FH, and G is the midpoint of both of those line segments. We don't have a picture here, so we got to draw one. EI is the same length, or is congruent to FH, and G is the midpoint of both of those, so obviously G is where they intersect. G. Prove triangle FEG, that'd be this one, is congruent to HGI. All right, 2-column proof. First, I got to state what's given to me. Okay. Now, because it's a midpoint, let's talk about what that means. So if it's the midpoint of EI, it would split EI in half. So we would know that EG is congruent to GI. And it's also a midpoint of FH, so it's going to split that segment in half as well. Okay, why do I know that?
Just definition of midpoint.
Nice. Definition of a midpoint. Definition of a midpoint. All right, so look, I have two sides. So I have to decide, can I somehow show the other two sides are congruent, or can I show the included angles congruent here? Jessa?
You can show that IGH is congruent to EGF delivered by.
Nice, perfect. Angle IGH, you said that beautifully, is congruent to EGF, vertical angle theorem. So then we can prove finally our triangles are congruent by what, folks?
C.
Not the congruent triangle ones. Oh, I think I heard it. SAS. S-A-S. Side angle side. Side angle side. Boom. Oh, how fun. Usually the CP, CTC we use after we know the triangles are congruent, then we complete other parts are congruent, but you're right. It can be used both ways, but we'd have to show everything's congruent to use that. Okay, I want to talk about this here.